Hey guys, Mr. Palmer here with a momentum review. I'm going to be going over the review problems involving conservation momentum and impulse momentum theorem. Let's take a look at the first two questions from a review I have here. The first one asks about an impulse that's going to take place, and the second is involving impulse calculating force. Okay, so let's take a look at number one. It gives us says a force is being applied to a 15 kilogram object. It tells us that it's accelerating from 10 to 25 meters per second, and we're looking for the impulse. So let's write out what impulse is, right? According to our idea, it's equal to the change in momentum. We can also write that as mass times the change in velocity. And we also know that impulse is force times time. So there's multiple ways that we can look at this. In the first case, we're given a mass and two different velocities. So in that case, we're looking at impulse as mass times the change in velocity to calculate it. So we're going to say the mass is 15 kilograms. Whenever we're finding a change, it's always final minus initial. So in this case, the final is 25 meters per second, and the initial is 10. When you're doing these calculations, make sure that your mass is in kilograms. If it's not, convert it, and that your velocities are in meters per second. And if they're not, convert it. So that's going to be 15 times 15. That's going to give us 225 kilogram meters per second, or because it's impulse, we can also write that as Newton seconds, which is an equivalent unit to kilogram meters per second. Part two, we're using the same principle. An 85 kilogram man, he's driving his car at 30 meters per second. It's going to hit a tree and come to a rest. You're given an amount of time and asked to find the force. So we're going to have to do two things here. We're going to have to calculate the impulse using mass and change in velocity. And we're going to have to say that that is equal to the force times the time, because it's asking us to calculate the force in a given amount of time. So for this was part one, we're looking at question number two. The mass of the man is 85 kilograms, and we're going to calculate his change in velocity. Well, his final is 0 because it says he comes to rest, right? It brings the car to rest when he hits the tree. And his initial velocity is 30 meters per second from the problem. So that's minus 30. And we're going to multiply that out. That should give us 2,550. And that's going to be negative because we're going to have a negative change in velocity here. We're going to set that equal to force times the time. Now in this case, the time is given to us with an airbag of 0.55 seconds. So force times the time, which is 0.55 seconds, equals negative 2550. If the impulse is negative, it's going to give us negative 4636. And it's a force, so that's in newtons, right? Our impulse was in Newton seconds. We divide that by seconds for time. We're going to get newtons. Now, if he stops without the airbag, it says we're going to have a different time. Well, it's the same impulse, right? It's the same impulse because he's still coming to a stop. It's the same change in velocity. So that's negative 2550 Newton seconds. But he's going to do so in a different time. So that's going to change the force. So the time in this case is 0.04 seconds. And so when we solve to get the force, we're going to be negative 63,750 newtons, which is much larger. And this is the whole idea of this impulse and momentum, right? If we're trying to have some kind of safety device like an airbag, if we increase the time to stop, right? In this case, we're going from 0.04 just hitting the tree to 0.55 hitting the tree using an airbag, the force is much smaller. Even though we have the same impulse, right? We have 2550. If we're increasing the time, we're decreasing the force necessary to stop. Okay? And I'll be right back with another set of problems with impulse and momentum.